Hello everybody, welcome back. Just a little issue from the last video, no big deal. I had the objective function, I just had the coefficients opposite. It should be 12. It's $12 for a sport utility and X is sport utility plus 8y because if you look at the last question, the y is the racing. So I got that from here, right? So 12 for an X, 8 for y. I had them in the opposite order. Not a big deal. We haven't used that yet, so that's good. It didn't affect our question. So that's going to be 12 times 30 per sport utility vehicle, plus $8 per race car, and like 40 of those. So that's going to equal 360 plus 320, which is equal to 680. So as we add more sport utility vehicles, we're obviously going to see that this increases, right? So I'm just going to steal this and add it in. And this will be 40 this time, which makes this 480 plus 320, which should be 800. Okay, and you're seeing the pattern. It's going up, and we knew that, right? If you make more of something and you're selling them, you're going to earn more. So this is 50 this time, so that'll be changed to 50. The y is staying the same across the values that I showed earlier in the graph. Okay, we're getting these values from here, right? 30, 40, 40, 40, 50, 40, 60, 40. That's the values that I'm using here. Okay, and that's going to equal, and this one here is 60 this time, which is 720 plus 320, which ends up being 1040. Okay. Now, as y increases, the cost will also increase. Let's do that now. So as y, so change that variable r to y. We're going to use y for the race cars. And as y increases, the cost increases as well. So I'm going to write those coordinates down. And those are right here. 60-10, 60-20, 60-30, 60-40. So as y increases, the cost will also increase. And I show that with 60-10, 60-20, 60-30, 60-40. I showed you got those values from the graph. So we're going to use the same calculation this time. The y value is going up by 10. So I'll replace this 10 with a 20. That makes this 160, which makes this 880. Again, you don't need to show all these calculations. You'll never have to do this again. This is us learning and exploring what happens for a maximum min problem. Okay, so the term is 960, and I'll do this again. And we already have that one, it's right here, right? 40, so we know what this one's going to equal. So that's part of the pattern that you're seeing, 1040. All right. So then you can just pick something in the middle. Just pick 3 points that are in the middle here. So 3 or 4 doesn't make a difference. It's whatever you want. So I'm going to go to my graph, go up top here, and I'll pick a few of them that are in the middle. There's actually one right here in the middle. Let's look at that one. That one there is, one's the only one we need actually, because we're going to do all the ones in the diagonal in a second. So we'll do the middle one here, which is 50, 30. This point here, 50, 30. Let's do that one. 50, 30. I'll steal this whole line. So we'll go 50 and 30. 50 sport utility, 30 race car. We end up getting 600 multiplied by, or sorry, added to 240. We get 840. All right, you can pick some more, but you'll see that it's smaller than these ones that are on the diagonal. And then, or in the corners, I should say, in the vertices, in the corners of the triangle. And then we'll look at the diagonal ones now. So the diagonal values there that we didn't look at yet, or we can look at them all. We can look at all 4. It doesn't make a difference. And they are right here, right? 30 and 40, 40 and 30, 50 and 20, 60 and 10. So we'll look at those. So 30, 40, steal this whole thing here. Be lazy. So 30, 40, and then 40, 30, and 50, 20, and 60, 10. So those were the 4 coordinates on the diagonal edge of the triangle of the feasible region. 30, 40, 40, 30, 50, 20, 60, 10. So now let's put those values in. This is a 30. That's 40. So that makes that 360 plus 320, which makes it 880. Or sorry, 680. My bad. Now we'll change this one to 40 and 30. And that would give us 480 plus 240, which would be 720. And then this one will be 50, 20, which would be 600 plus 160, which gives us 760. And then the last one on the diagonal, again, we already calculated this, but we'll do it again. 60 and 10, which would be 720 plus 80, which is 800, right? Okay. So out of all these, we go and we find the maximum. So the maximum is right here. Okay, the maximum. Right there. Same one, obviously, 60, 40. So the maximum is when we have 60 for X, which is 60 sport vehicles, and 40 for Y, and that'll give us a cost of 1,080. That was the max. And the minimum we found throughout this was the very first one we did here. All right, that's 680. And again, we did that again on the diagonal edge 680. All right. So the minimum cost can be found at 3040. See it twice. 30, 40, where that gave us a cost of 680. So in short, and this is what we're going to learn in the next section, is that your vertices, so the corners, right here, here, of your feasible region, will yield the minimum and maximum values. Anything in the middle, anything on the sides are going to be in between. That was the idea of this exercise. All that for that, sir? Yes, but you wanted to see the values happening. Okay? So that was the important aspect here. So I hope that helped. And in the next video, we'll look at example 2, where it's not a word problem, and just give us all the constraints. Okay? So thanks for watching, and we'll talk again soon in the next video.